Hi, welcome back. So I'd like to get started in this video by going over what we've done so far. So the code on the left here is the old main. Basically, we kicked things off from main and we started the game loop in there, which has now been moved over to kicking things off by instantiating a new game, right? So in our constructor of our new game, we will be going over very familiar code here and starting the scene and then triggering the loop from here instead of from main. The main loop currently is just the current scene, updating it and going through the display list and drawing all and triggering the loop again. All right, so are we ready to draw though yet? Are we ready to draw with this? There's a couple of steps missing, and we'll be going over that in some detail now. So we'll have an idea of what we're going to be doing when we code, when we're in the editor, right? We'll orient ourselves before we go there. So let's start from the game, right? When you're inside the constructor, we start our scene, passing in the current scene before we trigger the loop, right? So inside starting scene, we basically change the current scene reference via the key, the passed in key. And we then create any game objects, right? We go through the current scene's create method, which is responsible for creating game objects using this.add. So, and when we go to see what the game object factory is here, right? It's providing rectangle, which we're making use of here to create our game object. And let's see what we're doing. Currently, we are creating the game object and returning it. Unfortunately, we are not. See over here, we need to add it to the scenes display list upon creation. This is one way of doing it anyway. That's when we create the object, we immediately add it to the display list. And that's the approach we'll be taking with this method, basically. So once it's registered in the display list, we are currently not drawing anything, fair enough. But as you can see in the game loop, we do call this display list.draw, right? So anything that's been added to the current scenes display list gets drawn. So there's one thing we need to fill in if we're going to want to draw anything. But also, apart from that, okay, so this code over here, so until now we've identified, first of all, there's also this, right? We've identified we are missing the addition of the created game object to the scenes display list. We need to add that. And now we also have this missing implementation where we go through every game object and we render on it. But do we currently have a way to render on a game object? No, we don't. So we'll also need to go through our rect game object and text game object and add a way to draw. So let's head over to VS Code now and implement everything we've talked about so far. So back in our dummy phaser module, we can get started by implementing the drawAll method of the display list. And all we want to do here is iterate over every object in the display list and call a method draw on every object. We'll be needing to pass in context. Okay, it also doesn't exist currently, but we also, each game object will need to have something to draw with. So let's address that actually first. So if I go to direct game object, I can supply it with the missing draw method, which will get called every loop. And as you can see here, we're passing in the canvas rendering, the context 2D, which will need to get passed to it via here. So we'll need to pass this along. I'm still getting an error here because the text game object doesn't have a draw yet, and what we're typing this as, every game object here, right, is typed as either a rect game object or a text game object at the moment. So if the text game object is missing the draw, then basically TypeScript will warn me about this. So if I go ahead and add this to the text game object, then now we should have no errors shown, and we don't. And I'm copy pasting these things because these are basically it's all code we've seen before. So it's nothing new here. We're just using the Canvas API to draw either text or a rectangle. And with that, we've done almost everything, but maybe you can remember the initial design decision we made that upon the creation of a game object, we're going to also add it to the list, right? So I need to find the factory. I had a game object factory over here. And when we're adding the rectangle and when we're adding the text, we're currently not doing anything with the scene, right? We want to basically access the display list of this.scene display list and add the newly created game object. So in this case, that would be the rect. And in the case of the text, that would be the text game object. Okay, and with that, I think we can move over to main now and actually fill in at least one of our scenes. And so I'll get started by adding the box scene, which is currently making use of this.game, which we're not using. So let me just hard code that to maybe 200 because I know that our screen is going to be 400 high. So I'm basically putting it more or less in the center. Though it won't be in the center exactly because it depends on the origin of the rect, right? The origin of the rect isn't in the center of the rect, so the rect will not display exactly in the center of the screen by giving it 200, but that's good enough for us for now, for this dummy throwaway scene. So as you can see over here, I'm using a type rect game object, and this can be imported. And so while I'm at it, I'll import both game objects from the dummy phaser module, and that should stop, that should also tell me what it is, it should allow me to satisfy TypeScript's type checking. And yeah, over here we're doing the same thing with getting the game's width, right? So I know what the game's width is for now. I'll just hard code it to 800. And basically, I want to spin this up now to see what errors I'm missing. Okay, what things I'm missing. Okay, I'm in the wrong directory, so and I can see that the first error I have is cannot read property of undefined reading key. So I'm trying to create a new game. I'm trying to pass in a key to the current scene. I'm trying to access the key from the current scene, passing it to start scene. And if I go back to game here, okay. So as you can see, we created the box scene, but we're not actually passing it in. So that's the first issue, and we have to instantiate this. Right, so that's the first problem taken care of. Okay, so at this point, I seem to be losing the this context, right, when calling the game loop. In fact, as you saw me do over here, I basically added a breakpoint and I tried to see what this is. It's telling me it's undefined. And so obviously I need this to be the game object itself, not undefined. So you could have basically just console logged if you wanted instead, also in the game loop. So console.log, what is this? And that would give you the same expected behavior of undefined. So let me just get rid of the breakpoints. So what's happening over here is that when we're passing this call back to request animation frame, basically this game loop method is being called it's not being called like this, game loop, right? And whatever this ends up being, basically it loses the context. Okay, so in order to bind it to this current game object, we can use an arrow function. So the way arrow functions would work, so what I'm doing here is I'm wrapping the call to game loop within an anonymous arrow function. All right. And so this is also expecting over here, it's expecting one argument, which is a timestamp, which I can just forward along. Okay. And with that, this should work, because the way that arrow functions work is that where you're lexically, so basically where you're writing this arrow function, which in my case, I'm writing it within the constructor of the game class, right? And when this runs at runtime, basically the constructor, what JavaScript will do is it will create a new object, it will assign this to point to that new object, and inside the constructor, this is pointing to that new object, right? So when this is being parsed, right, line by line here, it gets to passing this. To pass in this function, it needs to create this function, right? And this, at this point in time, is pointing to this new object, which got created by this constructor, right? Actually, by the new keyword. So when you create the game, you'll be doing like new game, and the way that new works is it will create a new object, and then it will assign this to that new object, right? So when this is defined, then around here, okay. So when this anonymous function is defined, then this is pointing to game, the new object, this one, and then when it gets bound, right? So when this is being executed, then this anonymous function, this points correctly to this new game object, right? So that's basically all I'm doing over here. And in fact, because I'll be doing this more than once, you see over here, it might make sense to actually just introduce a new private method. I'll just call this RAF for request animation frame, inside of which I will do this so that I don't have to repeat myself here. So I can just do that. And now I can just do that. All right, and what I'm missing over here is that I needed to pass into the draw. You remember the this dot, what was it, CTX? Exactly. And so with that, now we are seeing the rectangle being drawn. But obviously, since I am not erasing the previously drawn rectangle or box, we're seeing this effect currently. So let's take care of that next. And to do that, I'll introduce a background color on the game config, which will default to the color that we used in our other video. So basically over here, I'm saying that the background color is optional with the square brackets. Its default value will be this color here. It's of type string. And I gave a description here. So in the game class, we'll need to handle this in the game loop. But before doing that, let's actually add an instance property of background color we can use. And set it at some point falling back to the default. All right, so now I have something to work with. I can remove this extra console log. And with that, we should be able to, yep, so that's expected, the speed at which the rectangle is going. So we are basically not limiting the amount of frames that get rendered per second. But other than that, it's good. And we can work on the frames next, actually. So what I would like in the game loop before doing anything, I need some kind of condition and return early. And of course, I will, in this case, call this dot request animation frame. My condition will depend on a delta time, which is the time that has passed since rendering the previous frame, right? To calculate the delta time, I'm going to need to timestamp minus the last time, basically the last, we can call it last render time, the last time we've actually been able to get past this if condition, right? Because after here I'll be setting this dot last render time, which will add soon to timestamp. And so I would like to make this actually configurable. So my intention is to add another property on the game config. Okay, it will format once I fix the errors I have downstairs. So basically the new property I've added is frames per second limit, which will default to 30. And this is the max frames per second the game will render at. Okay, so basically, once again, your machine can render at whatever frames per second, and we are here telling it limit that to 30. And to do this, basically, I'm going to introduce the last render time and frames per millisecond here. Okay, so that's the one I'm really interested in because I'm working on the milliseconds here. So I will be calculating that in the constructor here, is that frames per millisecond will be 1000, the number of milliseconds in a second, divided by the config.fps limit, and I'll default this one to 30 as we documented. So back to the game loop, I can continue with the condition here, right? So what I want to do again here is that if the delta time is so low that it hasn't yet exceeded our limit, I want to loop back, right? So if delta time is less than this dot, did I call it frames per second limit in milliseconds? Okay, so once again, we calculated delta time by subtracting the global time that has passed with the last time we were able to get past the if condition, which gives us the delta time, the time difference between frames. And if that time difference is not yet past our limit, then we iterate back. If not, we just continue as normal. And so with that, we should be able to cap, the speed of our box, basically. Now it's going a bit slowly, but we do have a way to alter that via configuration. So back in main.js, I have the option now to pass in the frames per second limit, and I can say that now we're rendering at 60 frames per second. So that's the box traveling a bit faster. And if I were to, for example, set it to 10 frames per second, the box is traveling slowly. So that, let's put it back to the default, and it's traveling a bit faster, but as you can see, the box's speed is dependent on the frames per second limit that we're setting. And this is a way that we can basically simulate a fast or a slow machine, right? So what we're seeing here is that on a slow machine, the gameplay is one way, and on a faster machine, the gameplay is faster, basically. So that's why I had left this comment over here at the beginning, so I don't forget to go over this, that we could make this independent of the speed of the machine by relying on the delta time, assuming we actually pass this through from our dummy phaser. So assuming that in the game loop, I'm actually passing in the timestamp I'm not using, but the delta time, I'd need to pass that in. And so that now, if I console.log the delta time, first of all, you see that the initial rendering is of not a number. And the reason that's happening is that I forgot to set the last render time's initial value in the constructor here. So if I this.last render time and set it to 0, that should fix that. So what was happening basically was that the initial render, this was not set, and then delta time becomes not a number, and we're just passing that over. So that fixes that. And as you can see now, the speed is, well, first of all, too fast. So I'm going to set that down to 1, the player speed, set it down to 1. And with a frame limit of 30 frames per second, this is how the game behaves. If I were to bump this up to 60 frames per second, then it's smoother. The box is moving smoother, but it's moving at the same speed, right? Our delta time has decreased here, around 20, whereas on 30, it's around almost 40. But even if I were to change this to 1, to 10, sure, the box is jumping around, so we lost the smoothness because the machine can't keep up. Basically, we have a really slow machine here, and the delta time, as you can see, is 100. But still, we have made the gameplay consistent, kind of. We have made it such that the box is moving at the same speed irrespective of this frames per second limit, right? Because we're using the delta time. So to wrap things up, let's just go back to the default frames per second limit, remove the console log, and at this point now I want to take care of basically using this.game instead of the hard-coded 800. I want to be able to, from my box scene, I would like to be able to access this.game. Obviously, can't do that at the moment because the current scene doesn't support that. But it's a simple matter of adding a set game method. And obviously, I do need this.game on the scene. So we'll add it. And what's missing now is that at some point before, at least before the create is called for sure, I need this.game to be actually set. So a good place to do that would be the game's constructor, right? When we're iterating through the scenes inside of our config.scenes, we could scene.setGame to this being the game being constructed. So that this should now actually be something and allow me to access the config of my game from each individual scene. So now I'll move over to adding the text scene, which is our missing scene from our previous video. And I can add that right over here. So it's a pretty simple scene, right? With a text game object and the key I set to text scene. On create, I simply create a new text game object. And that's about it. There's no updating going on. So let's not forget to add this to our game. And with that, we are missing only the functionality to switch between on click, which I will not add to the library itself, but I will simply use the same approach we did before. Simply adding an event listener of on click to reuse our start scene, right? The one we've defined inside our game. Such that when the current scene's key is the box scene, we'll simply change it to be the text scene. We'll start the text scene, otherwise we'll start the box scene. So with that, it's as you can see, we're not cleaning up the display list when we are switching. So that is one last thing I can do, is to on start scene, I can add here a this.currentScene.destroy call, which doesn't exist yet. And the intention here is that I have a current scene and I'm about to switch to a new scene, right? And creating it at the new scene's game objects. Before doing so, I want to basically remove the current scene's, the old one, before starting the new one, the current scene's game objects inside its display list. That way, when I switch back to whatever this current scene was, it will have a new display list, and we won't be seeing this. I mean, currently I'm seeing an error because of that, but let me just remove this again. So the intention is that I will not be seeing this game object from when I switched to this scene. That game object is still in its list. I switch back, and now there's two, right? There's that one, there's the one from before. I'm basically never cleaning up the display list when I'm switching the scenes. So that's what this destroy is going to take care of. As soon as I add it to the scene. So we can put this below create maybe. And all this is going to do is assign this .display list to a new display list. And with that sorts that out. Okay, and that's pretty much all I wanted to cover in this video.